Why was it so important to keep science and politics separate? There are several answers to this. First, it seemed to folks like Bush and Conant and the authors of Science: The Endless Frontier that only pure basic science, not applied science, got the best results. So they claimed that things like the atom bomb came from previous decades of pure research on quantum mechanics, research that was unconcerned with application. As we've seen, this was an ideological claim. This is a claim that places theoretical knowledge over practical and applied knowledge. Second, there was a claim that people who were political actually did not think as well as those who were free of ideology. Now, for this idea to work, there had to be a belief in something that was not true. There had to be a belief that there was such a thing as somebody who has no political ideology at all. But though many Americans of the Cold War believed that there were such ideology-free people, in actuality, such ideology-free people are like unicorns. They don't exist. So how did this criticism of ideology work in practice? Let's consider an example. What was the reason given for firing communists from teaching positions? The answer is not that communists would be a fifth column. It was not because they were going to organize revolution against the United States. The reason why communists should not be teachers was because they supposedly subscribed to an ideology and therefore could not think for themselves. Social psychologists developed an entire field devoted to understanding this form of irrationality, the kind of irrationality that dominated communists on the left and people on the far right, like Joseph McCarthy or his supporters. So social psychologists wanted to know which people would be likely to be anti-democratic or support an authoritarian government, and they wanted to know if some Americans, perhaps many Americans, would be like the Germans who had voted for Hitler or supported his policies. So their question was, what are the psychological traits of such people? According to the work of these social psychologists, democratic-minded folks had a collection of virtuous personality traits. These democratic people were open-minded, they were tolerant of complexity, ambiguity, and anxiety. They liked abstract thinking, they liked broad ideas, these people were flexible, they worked well with foreign or different kinds of people, and they thought for themselves. In contrast, the ideological people, the anti-democratic people, were intolerant of ambiguity. They liked concrete ideas. They were narrow, rigid, closed-minded. They were prejudiced and ethnocentric, and they were conformist or unrealistic. In this sense, conformist means not just wearing the same clothes as your friends. Psychologists defined conformity to mean agreeing with other people even when they are objectively wrong. So for instance, the psychologist Solomon Asch developed an experiment that asked people to match a length of a given line with a set of other lines. Those tested for conformity would be placed in a room of people who Asch had secretly paid to give the wrong answer. If the test subject conformed with all of those actors and agreed that it matched, say, line A, then he or she would be scored as a conformist. So being a conformist is not just about political ideology. It is about not seeing the world as it really and truly is. It also turned out that creativity was the opposite of conformity. So the more creative people were, the less conformist they were, and vice versa. And the most creative professions were scientists and artists, where the most creative scientists, in turn, were the least conformist. The most creative scientists were less conformist than everyday scientists. The mid-20th century sciences that studied reason itself were products of war. One of these was operations research. It was a science of war. Specifically, the science took its ontology from the bureaucracy of war. It focused on the location, pattern, and effectiveness of engagements with the enemy, the information extracted from radar and from aerial reconnaissance as filtered through the system. British OR scientists' recommendation for the deployment of radar sets and gun batteries were adopted and resulted in markedly improved defense of London. OR was also used to defend against German subs or U-boats. By tweaking such parameters as the size of convoys, the depths at which depth charges were detonated, or the relative number of days spent maintaining compared to flying anti-U-boat aircraft, the effectiveness of operations was ratcheted up for the British. During the early phases of World War II, the problems addressed by operational methods were concerned with the allocation of scarce radar stations, with the search techniques and convoy strategies in anti-submarine warfare. Yet OR rapidly expanded to the study of all aspects of the functioning of complex organizations and operations, including personnel and machines, these encountered in different branches of the armed forces. Eventually, OR became an integral element in the planning of major campaigns, including strategy and logistics, the training and management of manpower, the cost-effectiveness of weapons, and the allocation of resources. In the United States, scientists led by John von Neumann and Oscar Morgenstern contributed to operations research by inventing the new field called game theory. Examples of the kinds of problems already addressed during the war were the following. Given targets of specified value, physical vulnerability, and geographical distribution, and given the physical properties and aiming characteristics of weapons to be used in their destruction, how should effort be distributed among those various targets in order to maximize damage produced? Or, a productive system is being progressively destroyed. What fraction of its activity should be assigned to recuperation in order to maximize its total useful output at some later date? After World War II, at the RAND Corporation, operations research developed into a new science called systems analysis, which was the use of science to plan for future scenarios. One example is the basing study. Here, operations and systems analysis asked what was the best method of attacking the USSR from a cost-benefit analysis. They analyzed 400,000 different configurations of bombers and bombs. They specifically asked, was it better to build long-range or short-range bombers? One allows for bases in the United States, the other requires bases abroad. Long-range bombers are more expensive, but domestic bases are less expensive. Short-range bombers are less expensive, but they require overseas bases. Which is more effective? Which is a better way to attack the Soviet Union? These were the questions of systems analysis. To answer questions like these, RAND developed a new kind of scientific persona. This was the persona of a creative, flexible, interdisciplinary, out-of-the-box thinker. The new RAND scientist would be an expert, but a new kind, not one who was a narrow specialist. He, and it was always a man, not a woman in question, he would not be chained to a desk or a laboratory, but would develop big ideas in brainstorming sessions. If not in brainstorming sessions, RAND strategists like Daniel Ellsberg would invent and conduct games of strategy to foster their imagination and to run scenarios on how wars of the future might be fought. These war games were taken extremely seriously. The results and even the rules of play were classified for years. This kind of scientific, creative judgment would stand above all practical experience that had been gathered on the battlefield by generals. Thus, in a 1955 briefing on systems analysis, RAND physicist Herman Kahn noted that the successful operations research in World War II proved that mathematical analysis was often more effective than venerable tactical tradition. He commented that systems analysis established its worth in spite of the common belief that experience has been a better guide than theory in this kind of work. The civilian strategists at RAND Corporation argued that experience with obsolete, that is, non-atomic weapon systems, would hinder adaptation to a dynamic and novel threat environment, a threat environment characterized by atomic weapons. So, the scientifically credentialed analysts at the RAND Corporation argued that working through the steps of a simulation was the only way to acquire insight and skill in the operations pertaining to nuclear war. As Herman Kahn put it, there was no one with experience in the conduct of thermonuclear war, and that means we must depend on hypothetical experience. In significant ways, then, the claim of RAND that scientific expertise stood above practical skills developed through experience was a new kind of Taylorism. Here, it wasn't the craftsmen being turned into unskilled assembly line workers by time and motion studies. Here, it was generals being told by scientists who had never seen combat that they knew better how to fight wars than generals did. When officers would object that Kahn was ill-equipped to advise soldiers about military affairs, Kahn would retort, "General, how many thermonuclear wars have you fought recently?" Because RAND procedures had the veneer of logic and science on its side, it gained increasing voice in policy making. This was especially the case following the election of John F. Kennedy. For Kennedy's Secretary of Defense was Robert McNamara, and McNamara was a fan of RAND, and he brought RAND and its strategists, scientists, and accountants into the Department of Defense. So RAND methods would be used for running defense policy from strategy to contracting to weapons procurement and budgeting. Like all sciences, it began with making simplifications in its models of the world, so that its mathematical models could be computed. For example, Galileo's computations on the rate of freefall assumes that objects fall in a vacuum. Of course, we know in experience that things around us fall in air, and we know as well by observation that cannonballs and feathers fall at different rates. But Galileo says, and to this day students in physics learn to discuss gravitational acceleration as if there is a vacuum and feathers and bowling balls fall at the same rate. So what were the Rand assumptions? They assumed that nations are like people, and they assumed some things about people that are empirically wrong. They assumed that players in the game of nuclear strategy, that is the US-USSR, are flawless in execution. Rand assumed that both players have sufficient intelligence to deduce the best solution. Rand assumed that players know the planned strategy of all other players and all opponents. Rand assumed that players believe that deviation in their own strategy will not cause deviations by any other player. Rand assumed that an individual player has full or perfect information about exactly what will occur due to any choice made. Rand also assumed that individuals do not have preferences that are affected by what other people want to do. Now, these are obviously empirically wrong, but were Rand theorists crazy to believe that they could plan for World War III by playing games and making simulations based on false empirical observations? Perhaps, or perhaps not. However, Rand strategists had some good reasons to think that simulations were a good way to understand how the world works. Simulations of how molecules work were an effective strategy for scientists at mid-century. These simulations, which used unrealistically, empirically false simplifications of atomic and nuclear interactions. Scientists used these simulations because they were seeking to build a hydrogen bomb, and if they had not made simplifications, then their calculations would have taken so long that they never would have been completed. These simplifications allowed not only for the computation of nuclear interaction, it actually allowed for the design of a hydrogen bomb that worked on the very first try. The people who invented these techniques for simplification and simulation of nuclear reaction were the very Rand strategists who would go on to plan international strategy. So the question is not were they insane to make simplifications and simulations, but was it appropriate to use the same kind of simplifications developed for the nuclear bomb when thinking about international strategy? Rand strategists said yes. Others, critics of the Rand, said no. The science of international strategy, indeed even the claim that policy could be a political science, is not legitimate on this view. Critics said this is because people are more complex than hydrogen atoms and they can't be treated in the same way.